And now I'll move into the inlet section. In these next two settings, we're going to be choosing the active components for combination inlets in either on-grade or in sag conditions. We have the same options for both. You can either choose curb only, grate and curb, or grate only. So for a combination inlet on grate, which is going to have a curb opening and a grate, maybe we only want to include the grate as an active component. So it's not going to consider the curb opening as part of the capacity. And then if we're analyzing a combination inlet in sag, however, we may want to consider both the grate and the curb. The next two settings are going to control how gutter flow is considered in the calculations. I have these two settings listed here, but first let's focus on the image in the top left, which shows that frontal flow is the portion of flow that is inside of the gutter within the width of the grate, whereas the side flow is the portion of flow on the pavement that is not within the width of the grate. So when we look at the setting neglect side flow, if we have this set to true, only frontal views will be included in the inlet calculations. If we set this to false, then this setting here, neglect gutter cross slope for side flow, is not going to be applicable. Alright, so assuming that you want to include side flow, now we have an option if we want to neglect the gutter cross slope for the side flow. You're going to select false if the gutter cross slope is different from the road cross slope and you would like it to be used in the calculation of side flow factor when the grate width is less than the gutter width. We're going to select true for this option if we would like the road cross slope to always be used in the calculation for side flow regardless of the grate width. So I am not going to neglect side flow. I'll have that set to false, which means I need to set this setting. And I do not want to neglect the gutter cross slope for side flow, so in those instances where the grate width is less than the width of my gutter, I still want to use that gutter cross slope, so I'll set that to false. Moving into split downstream surface flow between gutters. This setting only applies to gutters that meet these two conditions. So first they have to be placed with the Use Gutter Sections tool that are going to pull from the terrain model. They also need to be discharging to the same inlet or outfall. If we set this to true, then the surface flow to the downstream structure will be allocated to the gutters proportionally by gutter length. Go ahead and set that to true. The next property is only going to be applicable to the United Kingdom. This is where you can enter your grading parameters for the different types. Moving into pressure hydraulics, I'm going to set the liquid label, which is going to describe the type of liquid used in simulation. Next, if you look at the pressure friction method, these are the choices that we have. Depending on the solver that you're using, these are the different friction methods that are available. So we're setting up the GVF rational, which means we can use the first two and the last one. We cannot use cutters. And then also we have a note down here saying that when we are using the rational solver, pressure pipes are going to be treated as conduits. Pressure pipe roughness is converted to conduit roughness, and no pressure loops are allowed. So I'm going to leave this setting set to Hayes and Williams. Next we'll look at the use of frequency factors when we're using the rational method. Frequency factors are used to aid in the pairing of large storm events when we're using either the rational method or the modified rational method. So within our calculation options, we are going to be specifying a frequency factor that will be paired with each potential return period, which will allow us to declare a multiplier, which is this C sub f value, for each average recurrence interval. And then that adjusted runoff coefficient is then used inside of the rational formula. So this is going to depend if you use frequency factors. If you do, then you're going to set this to true, and then you'll additionally need to set up those frequency factors, where you'll enter in your recurrence interval, and then you'll also enter in what those multipliers are going to be. If you are using the frequency factors, additionally, you have a toggle where you can allow runoff coefficient to exceed 1. So when the frequency factors are applied, do you ever want to see the runoff coefficient exceed a value of 1, true or false?